Just to touch on this topic a little bit, variability, you have different types of variance. You have error variance, you have true variance, and total variance. Obviously, error and true equal total. So what is error? Error is basically your human error. You're looking at the other steps. So if you have, let's say, the Mifflin St. Jeor model, right? It comes from the Harris-Benedict roots, but basically they found error within that mathematical formula and revised it. So Harris-Benedict has more error within its variance. What's another good example of error? So if you were paying attention earlier in the video or videos, may have misspelled a word. There's some human error right there. And then true error or true variability, the things are more absolute, so to speak. So both together equal your total variance. The book is not exactly that well defining in what true, total, and error truly are either. So that's my way or my context of it. We're starting to round it down here in chapter 3 with standard scores. So there's 3 different types of standard scores that we're going to really cover here, and the standard deviation, z-score, and t-score. We're going to go into detail which each of those mean and how to get to those numbers and how to apply those on a bell curve. And for the rest of this chapter we're going to talk about is on a standard bell curve. So there are 2 things I'm trying to introduce you to on this slide: what a bell curve, your normal bell curve or mesocurtic curve looks like, and what a standard deviation is. It has a summation notation of S. So if you paid attention, there's an S squared, now there's an S, and I'm going to show you the difference and how to achieve the 2. It's often used to illustrate the variability of a set of scores. So if you look at the bottom, you see the 0, the plus 10, the 20, the 30, and what do those numbers mean? And we'll talk about that here in the near future. How do we get to the S score? The S score is the S squared score square rooted. So now what I want you to do is to go back to where you saw that table and the table of 3.2, and I asked you to find what S squared was. Take the square root of that. Now you have your standard deviation. This slide, we're starting to get a little bit busy here. So again, we added a secondary column at the bottom. Let's just kind of orientate you to what's going on here. Okay, so I've introduced or added in the 0.13 on both ends of the curve. So if you look at the curve, it has a middle line. Now, what do you think that middle line represents? And if you said mean, you are 100% correct on what the middle line means. The -1, +1, now you see that down there below the numbers that came with the picture. So now if you go back to when we were talking about where the middle line would be, and you see a -1 that was a positively skewed, that means this -10 would be a 0, and that's where the middle line of this curve would be. Getting back into the nitty-gritty here, you see 0.1, or correction, the 2.15, the 13.59, the 34.13, the 34.13, the 13.59, the 2.15, and the 0.13. So basically you have mirrored images from this middle line going to the left and going to the right, and that's why you have +1 and -1 versus a 0 through 6. All of those are percents, and they need to equal up to 100%, basically. So what you're looking at is within a give or take of 1 standard deviation, you would be making up 68.26%. So that 3413 equals up to 68.26. And so now we expand our deviation set to a plus or minus 2. We're incorporating both of those 1359s. And now you're talking about 59.44% of the population of scores. And it keeps adding up, and it keeps adding up all the way to 100. So again, this is a busy slide. I'm trying to simplify it to the best of my ability, but without really being asked questions and how to figure it out for yourself. Really, it's just a busy slide to look at. So hopefully I've explained that well. If not, leave a comment at the bottom of the video, and I'll try to respond to you the best I can. So moving on, z-scores. If that last slide wasn't too complicated, let's take a moment, break, whatever you want to call it. Pause the video and let's try to tackle this again. But z-score, right? And you have your mathematical equation. You got your score minus the mean divided by the standard deviation. So this is going to give you another number to put on that bell curve. So I gave a couple of questions here. So go to line 1 and line 6. Basically, you're looking at the score minus the mean divided by a standard deviation, which in this case would be 0. For number 1 would obviously be 0, which would be the middle of that bell curve. The line 6, you see the score 5 minus the mean 3, and the standard divided by the standard deviation, which yields a 1.34 standard or number to put on your bell curve. So numbers tend to match the standard deviation on a graph, but for most cases, I think you're going to see like a 0 standard deviation, a 0 z-score, and then you're going to see a 1 or a very close point or decimal number related to that 1, and we'll get more into that here in the next couple of slides. T-score goes below the z-score on the distribution chart or the bell curve. The T-score is basically, this is how you achieve it. It's another way to create another grouping of people if you want to use that, or just another mathematical means. So again, off of table 3.2, line 6, 50 plus 10, which are standardized numbers, incorporating the z-score basically, yields the 63.699, or if you do it this other way, the 50 plus 10z, and it gives you a 63.42. Now, there's a question there, right? I can see that already. I can see some eyes starting to squint on this one. Why would literally the same number be different or yield two different results or have a small disparity between the two? And a lot of that has to do with the way how we do our math. So if I did the z-score and rounded up and then just use the z-score with the rounded number on the 50 plus 10z, then that's going to change the answer to that significantly. So unless you're doing things like sprints or something that has like a very narrow margin of disparity in between results, rounding is probably not going to be the most astute way to do that. But if you just slap some numbers into a calculator and hit enter, it's going to give you a more refined number, so to speak, as long as you punch in the right number of stuff in, equal stuff out when it comes to a calculator. So make sure you're following the order of operations appropriately. All right, so here's my example to give to you people about how to make light of everything here and try to tie it all together. Again, this is a pretty difficult chapter to kind of swallow by just reading it alone. So here I'm trying to give you an overly simplified example here. I came up with my own raw data just to put you through the ringer, so to speak. So on this slide, you see my percentile, and you can rewind to a previous slide and go over what percentile is. You got the raw scores represented here. You got 6, 8, 10, 12, 14. And how they represent as far as standard deviation, the z-score, and the t-score. So again, standard deviation generally has a 0 as your middle or your median, your mirrored aspect, so to speak. And you got your -1 and 2, and you got your +1 and 2. That should always be standard practice for you to do, is just go ahead and slap those 3 items on a bell curve whenever you're trying to do some homework or trying to work on an exam. Plus all the percents on a previous slide. You gotta make sure you understand the percents as well. So here's what I want you to do. I want you to pause it for a second. I want you to go over and figure out what the z-score and the t-scores would be on this bell curve, and after you got an idea, post it to the comment section, or just let the video continue on. But at least try to practice. If you don't know how to get to it, look at the next slide and you'll have the answers there. If these were the answers you got, pat yourself on the back. If not, these are not the answers you seek. As you can see here, I filled in the blanks. So the z-scores, they mirror zeros, but the +1s and the +2s changes, and the -1s and the -2s changes. There's a couple of things that I can talk about here. So you follow the math to get a z-score. Basically, you have a plus or minus of a 0.635. And you can do two things with that, right? You can start at the 0, you can add up to the 6.4, the 0.64, or whatever number I rounded up here. And you can add another 6.4 or 6.35, get to the 1.27, right? The give or take there is obviously I rounded up for the 6.4, but I didn't for the 1.27. The opposite of that is you would subtract that, and I forgot to put a negative on the negative 1 number, but here you can see it, conversely goes down as opposed to it going up. You can do the math on each of the scores per the line, and it'll give you that number, and you can just slap it as it comes. Or you can start at 0, and if you know the interval between the 1 and the 2, you can literally just slap those numbers down. You can do your own math, basically. Same thing with the t-score. So again, the t-score here, 50, because 50 plus 10 times 0 is 50. And if you know the frequency between the plus 1 and the plus 2, which here I've written out as 6.37, you can subtract 6.37 to get to your negative 1, subtract another 6.37 to get to your negative 2, subtract a negative 3.7 to get to your negative 3, and so forth. Just keep that in mind as well as you're going through the class. There are some shortcuts, and there are some less than fortuitous shortcuts. So make sure you follow the numbers, you track the numbers, you put an S where an S belongs, you put an S squared where the S squared belongs. If you're using a calculator, again, stuff in is stuff out. So human error will get you in that variance. So literally out of all of that, this is the only summary I could come up with. This is more than likely broken down into 2 different videos. If it wasn't, I highly doubt it was, but if the video wasn't, it was a lot to go over at one time. I hope you take the opportunity to watch it a second or third time just to really hammer in these details. Again, take the time to read ahead. There's no way you can pass this class without taking the opportunity to read. And I know it's tedious, and I know it's a bit arduous as well. So just take the time, invest it wisely, even if it takes 2 to 3 hours to get through one chapter. Again, I'm not really 100% sure how I can pass my notes around. I do take notes every chapter, specifically from this one on. So I'm trying to help you guys, make an A in this class. Obviously, I'm trying to make an A in this class as well. But the concept here is, to have a face behind the material. What else is there? If you have not yet subscribed to the channel yet, this is how you do it. Basically, you type me in, you find me out, go over here, hit the subscribe button. When you see the subscribe has occurred and you have subscribed to the channel, it'll give you the option for the little bell icon. Once you click that, now you have a full subscription to the channel. So at that point, when I post videos, you will get updates. You will get a little notification that says, hey, congratulations, you got a notification from Andy who just posted a new video. Hopefully it's another chapter video. Sometimes I do post some random stuff too. I am a guy. My kids love to play video games, and sometimes we record the shenanigans that goes on with that. So I know it's a big chapter. I'm pretty confident y'all didn't enjoy it, but it's just material we got to eat. So again, my name's Andy Dents. The best way to contact me is off of Facebook or the email system on the class. So thank you.